This question belongs to programming subject and was asked in GATE CSE 1991. So the question states, give short answers to the following questions. Convert the following Pascal statement to a single assignment statement. If x is greater than 5, then y equals to true, else y equals to false. Let us see the answer for this. So we have an operator called an ternary operator. First, let us see what this program is doing. If x is greater than 5, then it assigns y the value true, else if x is less than or equal to 5, then it assigns y to false. So we have ternary operator which is given by this. So here its basic syntax is a condition followed by the operator, and then it has C1 and then colon C2. C2 means the statement which is executed when condition is true, and this is executed when condition is false. So how can we rewrite the given statement? We can rewrite this as x is greater than 5. We are asking this, and if it is true, then we are assigning y to true, else we are assigning y to false. So let me write this over here. It is equivalent to x is greater than 5, then y equals to true, else y equals to false. Now let us see second question. So in the first one we have just used the ternary operator of Pascal. Now the second option says convert the Pascal statement. This is the statement. What is the statement? It is repeat S until B into an equivalent Pascal statement that uses the while construct. So we have to rewrite this using the while loop. So what's the syntax of while loop? The syntax of while loop is something like this. While a condition, and while that condition is true, it will execute some statements. Let us see S1. So it will keep on executing S1 till that condition is true. So we can rewrite this as while B we will do S. While B we will do S. So this one is equivalent to while B we will do S. This parentheses are optional if there is a single statement. We can write this without the parentheses also. Now let us see the question 3. So part 3 says obtain the optimal binary search tree with equal probabilities for the identifier set A1, A2, A3 with if, stop and while. So let me tell you what is a binary search tree. In binary search tree, we have a node and all the values which are less than, if this is x, then it will have all the values less than x, and it will have all the values greater than x. Now suppose we have a tree like this. This has A, this has B, this has C, and this has T. Okay. Now, what is an optimal binary search tree? Let us suppose A occurs with a frequency f1, B with a frequency f2, C with a frequency f3, and D with a frequency f4. So, then what is the cost of searching A, B, C, and D? So, it is equals to A into f1. A is the cost and f is the frequency, plus bf2 plus cf3 plus df4. In binary search tree, optimal binary search tree, we try to minimize this frequency by creating a tree such that this value is minimized. Here we will have A. So the values that will come over here are, in case of A, B, C, and D, we will have the number of times it was searched. A can be searched in one comparison, so we will have 1 into f1. B can be searched in 2 comparisons, so we will have 2 into f2. C can be searched in 2 comparisons for this and this, so it will have 2 into f3, and D can be searched in 3 comparisons. First with this, then with this, then with this. So we have 3 comparisons. So we need to minimize this value. Minimize the value. Now let us see. Here we are given that we have 3 symbols A1, A2 and A3 such that all have equal probabilities, Let us suppose 1 by 3, 1 by 3 and 1 by 3. So A has frequency 1 by 3. Frequency or probability, we can say all three are same. Which means it do not matter which node comes at what place. So we can have various representation. Either it can be like this, A, B and C can be anywhere as all has equal probabilities. Or we can have it like this, A, B, C. Or we can have it like this, A, B and C. We can have various structures, like we can also have something like A, B and C and various. But all these will have equal cost. The cost will be equal to A1 with a frequency 1 by 3, A with a frequency 1 by 3, B with a frequency 1 by 3, plus C with a frequency 1 by 3. So this is the cost. And for this, the cost will come out to be A with a frequency 1 by 3. But here, what is the number of comparisons for A? A will have 1 comparison, B will have 2 comparisons, C will have 3 comparisons. So it is equals to 6 by 3, which is equals to 2. Now let us see this one. A having 1 comparison with a frequency 1 by 3, B having 2 comparisons with a frequency 1 by 3, C having 2 comparisons with a frequency 1 by 3. So it is equals to 5 by 3, 1 point something. Let us suppose 5 by 3 and this is 6 by 3. So this is the optimal binary search tree. Optimal means it will have minimum frequency. So the answer to this question will be, the tree will look something like this. A1 over here, A2 over here and A3 over here. We can have A1, A2, A3 over any places, but the structure will be like this only.